Torrential rains and typhoons have occurred more frequently recently, which is believed to be attributable to climate change. Natural disasters continue to increase. Sediment disasters can destroy property and cause the loss of life in an instant. What prevents the threat and protects humans? It is the SEE ground anchor. Japan is prone to typhoons and heavy rains, and the steep mountainous terrain has made it vulnerable to sediment disasters. Sediment disasters are awful disasters that can destroy property and cause the loss of life in an instant. Indirect damage caused by sediment disasters should not be overlooked. Traffic disruptions caused by sediment disasters also generates huge economic losses. There are 520,000 potential locations for sediment disasters in Japan, and 1,000 sediment disasters have occurred on average annually for the last 10 years. Landslides are an example of a typical sediment disaster. How does a landslide occur? A landslide is the phenomena of the ground surface of a certain area of a slope sliding downward in that shape to some degree, and is mainly caused by underground water. The landslide terrain can be largely divided into two layers. They are the hard layer or base rock layer of the foundation and the earth layer or moving bed which covers the foundation. The clay layer between the two layers, which becomes prone to sliding when it contains water, is called the slip surface. When rain permeates and the ground level rises, it receives buoyancy effects and gravity increases to a level where the moving bed can no longer tolerate the weight, causing it to slide. One effective method to prevent a landslide is to use a ground anchor. The anchor mainly uses a high-strength cable called a pre-stressed concrete steel strand to connect the stable underground base rock layer and the ground surface to apply tensile load, thereby stabilizing the slope. The ground anchor was first developed in Europe in the early 1930s. The method spread widely across the world due to its effectiveness, and standards began to be established in the 1970s in various regions. Both anchors and standards have been revised as anchors became more prevalent. One of the main features of the anchor method is that it allows a wide range of design under various conditions, and it does not require large-scale civil engineering work when compared with other methods. Because of the advantage, the ground anchor was introduced to Japan in the 1950s and has been used widely. In the 1980s, the Japanese Geotechnical Society standards were established, which led to the establishment of design policies and raised awareness of corrosion protection. As a result, the reliability of the method increased, and there are 1,300 construction sites a year in Japan that use anchors. Now let's have a look at the mechanism of the anchor method. The ground anchor is comprised mainly of the anchor body, the tensile part, and the anchor head. The anchor body transfers the tensile load to the base rock via the grout. The tensile part transfers the tensile load from the anchor head to the anchor body, and it is comprised of the tendon, the sheath, and other covering materials that prevent corrosion of the tendon. The anchor head is made up of the tensioning element, the bearing plate that supports it and transfers the anchor force to the structure, and the cap and other parts that protect the head. The anchor body, tensile part, and anchor head are available in a variety of configurations. Thus, it is important to select the ground anchor of a proper structure based on the purpose, site condition, and service period. Recently in Japan, degradation of ground anchors that were installed when there was no corrosion protection performance standard has become an issue, and the need for ground anchor maintenance during its service period has become recognized. Thus, the corrosion protection property, maintenanceability, and quake resistance in consideration of frequent earthquake disasters are of importance. Now let's have a look at the structure of the SEE ground anchor. The anchor body of the SEE anchor is categorized as a compression type. The compression type anchor transfers the tensile load with the friction force to the foothold, and the tensile load is generated with the bottom of the anchor body as the base. As a result, the compression force works on the grout. Because of the structure, it is classified as a compression type anchor. Because the grout is resistant to compression, no crack occurs, and the grout also works effectively as corrosion protection. The tensile part is made up of pre-stressed concrete steel strand, with the entire length coated with anti-corrosive oil and polyethylene. There is no need to be concerned about the corrosion of the tendon because of the high-grade double corrosion protection structure. The anchor head is firmly fixed in the original nut-fix type method. The tensile load of the ground anchor may fluctuate during the service period. However, it can be easily adjusted with the nut-fix type method, and maintenance is also easy. It is also confirmed that the method allows maintenance of tensioning performance even when there is a shock load of an earthquake. In other words, the SEE anchor has a great advantage in terms of the required three properties of corrosion protection, maintenanceability, and quake resistance. Let me now introduce how the SEE anchor is manufactured. The SEE anchor is manufactured at the ISO 9001 certified Yamaguchi factory. The production process mainly includes the following: material arrival, stranding, coating, measurement, sleeve compression, groove cutting, assembly, packaging, and shipment. The pre-stressed concrete steel strand and other materials to manufacture the tendon of the SEE anchor arrive at the factory. They are strictly inspected to see whether they meet the requirements. The tension test is performed with the pre-stressed concrete steel strand to check the strength. We carefully choose materials that suit different uses. A bundle of strands is further stranded in-house to make larger tendons. The first manufacturing process is the tendon coating. Anti-corrosive oil is infilled around the tendon for corrosion protection. It is then coated with polyethylene resin. The coated tendon is cooled and wound on the drum. The next step is measurement. The tendon is cut into certain lengths on the measurement line. After it is cut, it is rolled before the tensioning element, or sleeve compression, is attached. The sleeve is compressed when it goes through the dice to be attached to the tendon. Groove cutting is performed on the compressed sleeve. The compression element is assembled and waterproof processing is performed to finish the anchor manufacturing. The anchor is packaged and sent out to the work site. Now let's have a look at how the anchor is installed. The ground anchor installation process mainly includes hole drilling, grouting, tendon insertion, tensioning, and head processing. The first step is to drill a hole at a certain angle to the foothold. The hole drilling location is decided and a boring machine is used for hole drilling. The hole drilling is followed by grouting. The quality inspection of the grout flow value and a compression test are performed before grouting. The grouting pipe is then inserted for grouting. The pipe is removed after grouting and then the tendon is inserted. The casing is pulled out to a certain location after tendon insertion and the grout is pressed in to make the anchor body. It is cured and tensioning work is performed when the grout strength reaches a certain level. The stopper sheath is attached to prevent corrosion of the backside of the bearing plate. The pressure receiving plate is installed, and then the bearing plate and nut are attached. This is followed by tensioning work. The jack is set up. Tensioning is performed while the quality is being checked with the tensile load and displacement of the anchor head. The nut is fastened when the tensile load reaches a certain level. The final step is to place the cap and fill it in with anti-corrosive oil to prevent corrosion. The SEE ground anchor is used on various sites for its reliability and performance. In addition to the prevention of landslides, the SEE anchor has also been used on a broader range of sites for their reinforcement, such as the foundation of structures, river embankments, fishing piers and other ports and harbors, and erosion control structures. We sincerely hope that you will use the SEE anchor to protect people from natural disasters and develop safe and secure infrastructure.